Hi, today we are looking at correlations. So what do we mean by a correlation, or what is a correlation? It is examining the relationship between two variables. So a correlation seeks to establish the relationship between two variables. Remember, a variable is just something that is measured or investigated in a piece of research. So a correlation is looking to establish the relationship between two variables. For example, we might look to establish the relationship between stress and the number of family members you have. So we might find that the more family members, the more stressed you are. We might find the less stressed you are, the more family members you have, who knows. But what we would do is we would be examining the relationship between those two variables. Does one have an effect on the other? So the thing about correlations is they are non-experimental. So I just want to go through a couple of differences between experiments and correlations just so that you can identify the difference. In an experiment, you'll know that we have a DV and an IV. So the one that's the variable that is manipulated or changed and the variable which is measured. In a correlation, we're not manipulating or changing anything. All we are doing is we are measuring two variables. So no IV, DV. Technically, so we do have a variable, we have two DVs because we have two that are being measured, but we don't call them DVs, we just call them variables. So in an experiment, we have our IV and our DV. Correlation, no IV, no DV. In an experiment then, we are seeking a difference. We want to know if there is a difference between condition 1 and condition 2. In a correlation, we are just seeking a relationship. We just want to know, does one have an effect on the other? And that leads on then to our third difference. In an experiment, we can establish cause and effect. In a correlation, there's no cause and effect, or cannot establish cause and effect. Okay. So in an experiment, we know that if we set up our experiment and we are going to be, we have two conditions, and we know that by changing something in the second condition, we know that if the results differ, then one variable had an effect on the other. We know that, for example, an increase in caffeine improves memory. When it comes to a correlation, we can't establish cause and effect because we're not changing or manipulating anything. We've just got two separate variables that are measured. So when we come to describing correlations, a correlation can be described as a positive. So within a positive correlation, as one variable increases, the other variable increases. So, for example, the higher the stress levels, the more family members are present. Okay, as one variable increases, the other variable increases. Or the next type of correlation that we could have is a negative one. And in a negative correlation, as one variable increases, the other variable decreases. That would be a negative correlation. The higher the stress score, the less family members there are. And lastly then, another final way of describing a correlation is just zero. Zero correlation. There is no relationship between the two variables. So it's just zero. There's no way to describe it. It's just zero correlation, no relationship established. Okay, so displaying correlations. If we wanted to visually display a correlation, it will always be through a scattergram. Now we'll be doing a wee bit next week on displaying data. So a scattergram is where you have lots of points plotted, but they're not joined up. Okay, because joined up would be a line graph, wouldn't it, if these were all joined up? So just lots of points plotted. So if we were going to visually display a positive correlation, remember, as one variable increases, so does the other, it would look something like that. So what you can do is you can draw a line of best fit, and then you can clearly work out, right, that's a positive correlation. You don't have to do the line of best fit. If it's a positive correlation, you should generally see that trend. Remember, as one variable is increasing, so let's say this is number of family members, and this here is stress score. So you would have participant 1 has 6 members in their family, and they also recorded a stress score of 40. So they would be plotted here. Participant 2 has only 1 other member in their family, and they've recorded a stress score of 5. So again, they would be down here. So that is how we go about plotting our points on our scattergram. And again, a positive correlation will show that general trend from bottom left to top right. Positive, as one variable increases, so does the other. Moving on then to a negative correlation. So remember, it's as one variable increases, the other decreases. So a negative correlation will follow that type of trend. Again, we could draw a line of best fit if we wanted. And general negative correlation goes from top left to bottom right. Okay, so see the difference there between the positive and the negative. So you'll see as one variable is increasing, so number of family members from 0 to 10, stress score, the other variable is decreasing. So the more members of the family there are, the lower the stress score. Okay, so participant 4 has 5 people in their family and record a stress score of 15. Okay, participant 9 has 9 people in their family and only record a stress score of 4. So again, they would be down here. That type of trend would be then our negative correlation. Zero correlation, no trend is visible. It's just, remember the zero correlation, no relationship can be established between the two variables. There's no trend, there's no way of identifying if one variable has an effect on the other. Okay. Now the last wee bit, you'll see that sometimes a correlation isn't going to follow this absolutely perfect trend for positive or negative, and it can be more difficult then to work out, well, is it a positive correlation or is it a negative correlation? How strong of a correlation is it? So there is a way of identifying the direction and the strength of correlations, and it is using, it is using a correlation coefficient. Shh. Sorry, it's my cat. So correlation coefficient is basically, it's like a mathematical process that can be used, and it's computer based, so you'll never ever have to work this out. It's computer based, and what it does is you would input your data, so you input your 2 sets of scores, and it will come up with a figure, and that figure will range from -1 to +1. Sorry, I'm going to just turn, oh no, this is going to mess up your video. Okay, so that ranges from -1 to +1, and obviously then you have 0 in the middle. So if, when you input your 2 sets of scores, let's say it came up with a value of -1, that it never happens, but if it did, -1 is a perfect negative correlation. which means then that +1 would be a perfect positive correlation. 0 is our zero correlation. Okay, so using that correlation coefficient line, that scale from -1 to +1, we are able to tell, when we get our numerical figure, we are able to tell whether it's the direction is positive or negative, and whether it's a strong or a weak correlation. So anything that's going to be from, say, -0.5 this way is going to be a strong negative correlation, because it's getting closer to that -1, which is our perfect negative. So we could describe anything there as a strong negative. And anything then that goes from -0.5 up to 0 is going to be a weaker negative. Same on the other side then. If we find 0.5, anything from +0.5 to +0.1, to +1 is going to be a strong positive. And then anything between 0 and +0.5 is going to be weak. Okay, so that can be just a better way for us to identify not only if it's a positive or negative correlation, but also how strong of a correlation is it, without having to just rely on making our own judgment based on a scattergram. But again, that mathematical figure is worked out by it's like a computer-based test. So you'll never have to work that out. But if you were given a correlation coefficient value of 0.87, then you could say, right, 0.87, how would I describe that correlation? Well, it's 0 point something, so it's a positive, it's on the positive side of things. If it had a minus in front of it, then it would be minus, but it doesn't. So plus 0.87, that's going to be way up here somewhere. So I would describe that as a strong positive correlation. If I was to get a correlation coefficient value of 0.33, again, we know because there's no minus in front of it, we know that it's positive. And 0.33, well, that's going to be about here, too close to 0. Therefore, we would describe that as a weak positive correlation. If we got minus 0.7, again, minus, so we know it's a negative. 0.7 is going to be down about here somewhere, so we could say that's a strong negative. And so on. Okay, and that's correlations. So what we're doing, we're establishing the relationship between two variables. We're just measuring two different things and seeing, does one have an effect on the other? If it does, then it can either be in a positive way or a negative way. So as one variable increases, the other increases. Or as one variable increases, the other decreases. Either way, one is having an effect on the other. So they are correlations. If we find that there is no relationship between two variables, we just describe that as 0. It's just a 0 correlation. There's no correlation. If we're going to plot correlation, it's always on a scattergram where we put in plot our points and look to see if there's a trend. If it's too difficult to do that, or if we want to be more precise, we can use a statistical test that will work out a figure called the correlation coefficient. That figure will always be from -1 to +1. That's the correlation coefficient scale. The closer it is to -1, the more strong, we can describe that then as a strong negative correlation. The closer it is to +1, then we'll describe that as a strong positive correlation. The closer it is to 0, the weaker the correlation gets. So if it's on this side of 0, it's a weaker negative. If it's on this side of 0, it's a weaker positive. Okay, so I have emailed you a worksheet to go through and a wee exercise, and there's also another wee exercise in the textbook you can do for this. Okay, any questions, just give me a shout. Good luck, bye.